This video is going to address and cover end behavior of polynomial functions. So we're going to look at how do we determine the end behavior of a polynomial function. And with this one, we've got some stuff set up already. So end behavior is talking about what is happening to the graph as we go to the left and to the right on the x-axis. So the left side, our left end behavior, is always going to be as x goes to negative infinity. So as we're going to the left on the x-axis, is the graph or the y values increasing or decreasing? And then the right side, we're looking at as our x values go to positive infinity, so the right side as it goes forever to the right, are the y values increasing or decreasing? And so there's a couple different things that determine that. The first thing in our polynomial that determines end behavior is whether it is an even degree or an odd degree. So the degree being the highest degree or the degree of the first term in our polynomial. Even 2, 4, 6, 8, odd 3, 5, 7, 9. So that's going to determine one thing. And then the second part of it is the leading coefficient, whether or not that leading coefficient is positive or negative. So an example of a positive leading coefficient with an even degree might be 3x to the fourth plus 5x squared minus 1. So we've got a positive leading coefficient and an even degree. So we're looking at the number in front of x and the degree, the highest degree of x. So that would be a positive even. Or we could have, let's say, negative 4x to the sixth minus 2x squared plus 7. So now we've got a negative leading coefficient, and we still have an even degree. So this would be a negative even. So positive even is this box. Negative even is here. So we've got positive leading coefficient, even degree. So the arrows for this one are going to go up on the left and up on the right. It might look something like this. So it's going to be going up or increasing on the right side, and it's going to be increasing on the left side. So as we write this, we would say as x goes to negative infinity, so as the graph goes to the left, it's going up towards positive infinity. So we would have positive infinity for f of x or our y value. Now if we're going to the right, as the graph is going towards positive infinity on the right, the graph itself or the y values are also increasing. So we would say that f of x or y goes to positive infinity. If we look at a negative leading coefficient with an even degree, that one is going to have end behaviors that go down on the left and down on the right. So it might look something like this. So we would say as x goes to negative infinity, so the left side of the graph, f of x or y is going down towards negative infinity. So we would say as x goes to negative infinity, f of x goes to negative infinity. On the right side, as we go to positive infinity on the x-axis, so we're going to the right forever, the graph's going to keep going down towards negative infinity. So we would have the left side would be as x goes to negative infinity, f of x is going down to negative infinity. And the right side, as x goes to positive infinity, the graph is also going down towards negative infinity. Now we've got an odd degree, and again we've got a positive leading coefficient and a negative leading coefficient. So examples of this, if we have a positive odd, that would be, let's say, 2. which is a positive number, x to the third plus 5x squared plus 1, so that would be a positive odd. That's going to be this box. Or we could have a negative odd, so let's say negative 4, and remember we're not looking at odd or even for the leading coefficient, we're looking at the sign, positive or negative. We'd have negative 4x to the fifth, there's our odd degree, plus 3x cubed minus 1. So this would be a negative odd. So now we're going to look at what the arrows do here. With positive and odd, it's going to go down on the left, up on the right. So it might look something like this. Now as we're going to the left, so towards negative infinity on the x-axis, the graph is going down towards negative infinity. So we've got, as x goes to negative infinity, f of x goes to negative infinity. And when we go to the right, towards positive infinity, we notice that the graph is going up here. So that means that as x goes to positive infinity, f of x, or the y values, are also going towards positive infinity. For negative leading coefficient and an odd degree, this one's going to go up on the right, down, or I'm sorry, up on the left, down on the right. So it might look something like that. So we're going to the left towards negative infinity on the x-axis. So as x goes towards negative infinity, f of x, or our y value, is going to go up towards positive infinity. As we go to the right side, as x goes to positive infinity, our graph, the values of y, are going down towards negative infinity. So that's how you would write the end behavior. There's a little trick also to look at this. If you notice, positive leading coefficients, right here, both of the right sides are going up. And if we look at negative leading coefficients, both of the right sides are going down. So we could say that positive leading coefficients go up on the right. So it doesn't matter if it's an even degree or an odd degree, it's going up on the right side with our positive leading coefficient, and we can say that negative leading coefficients go down on the right. So negative leading coefficients over here are both down on the right. So positive and negative determines the right side. Positive leading coefficient up on the right, negative leading coefficient down on the right. So then if we look at our left end behavior, notice that even degrees, if we're looking at this row here, the left side of our even degree with a positive leading coefficient matches the right side, so they both go up. And if we switch that to negative, they both go down. So even degrees match left and right. So if our right side's going up and we have an even degree with a positive leading coefficient, we're going to go up on the left. If our right side is going down with a negative leading coefficient and we're an even degree, it's going to match and go down on the left. Now if we look at odd degrees, notice that the right side here is going up, the left side is going down. If we switch to negative, the right side's going down, the left side is going up. So odd degrees are opposite on the left and right. So we're going to look at positive and negative leading coefficient for the right side, and then we determine the left side by going same side for even degrees or opposite side for odd degrees. I hope that helps. I know this one can be a little bit tricky for a lot of people, so if you like this video, please subscribe and stay tuned for more.